Math 3, Unit 10, Lesson I, or for Worksheet 9. Okay, so today we're basically just putting together multiple things that we know. We are going to graph a cosine graph. And then, do you know what kind of graph this will make?
It's like a straight.
Very good, a straight line. Because this really means like y equals 1. So it would be a horizontal line. And then we're finding the points that they connect. Okay? So let's go ahead and graph this one first. And you're going to want to graph these in different colors. So I'll put out the pencils again in case you need them. Okay, so going to cosine graphs. Okay, you're going to need to remember how to graph cosine functions and sine functions. Okay, with cosine functions, and I'm just going to kind of make a little note here. Do you guys remember where your original zero graphs are always going to be? And actually, I'm going to put cosine zeros. So which points are our cosine zeros normally at? Okay, so pi over 2 and 3 pi over 2. Okay, we always remember one thing is that there's going to be 5 key points. So on the cosine graph, these are your zeros, and then remember this one goes above, before it goes above, and then in the middle of the two it goes below. And then after here, it ends up going above. Okay, does that make sense how I have that written there? Okay, so that's what you would need to remember for your cosine graph. And I'll kind of do the same thing when we get to sines here in just a minute. So, we have where our zeros should start. And then we know that, what does that 2 right there mean? Good. Amplitude of 2, which means we're just going to be going up 2 and down 2 when we're going up and down. Okay? And then what does this plus 3 mean? Very good. It's going to end up shifting up 3. So I'm just going to put up 3. Or we should probably put shift. Okay. Okay. So if my original point here for 0 is at pi over 2, instead of making my mark here, I'm going to go where? Up 3. 1, 2, 3. So this is my new 0. Okay, normally we would have a 0 at 3 pi over 2, and that one I also am going to move up 3. Okay, once you have your zeros, then you can make your other up and down points. Okay? So starting at 0, instead of my normal 1, my amplitude is 2. So that means when I'm going up, I'm going to go up 2. Make a point. Okay, and then I go to the spot in the middle, and this one I'm going to go down 2. Very good. And then we go after our 0, and this one I'm going to go up 2. And then we make our curve to the best of our ability. Okay, and for this paper, I just want to make sure for everybody that we want all of our answers in radians. Okay, so we have one graph. Now I'd get a different color. And we're going to do our other graph, which we know in this case is going to be at 1. And we're going to go ahead and draw our line here at y equals 1. You could use a ruler to make a straight line. But we can pretty much see where the two lines intersect, or the two graphs intersect, which is where? Pi. Okay. Also, the other thing is that we should be labeling these. So this graph is f of x, and this graph is g of x. Okay. So we're pretty sure these connect at pi. There's going to be times when you're just kind of estimating, and it even says on B, estimate where you think the x coordinate is. But we can do it algebraically to find the exact, for sure, point that it's intersecting. And so we're going to do it both ways. So C, we're going to follow up with an algebraic solution where f of x equals g of x. So that is where I'd write out 2 cosine of x plus 3 equals 1. So all we're doing is setting our two equations equal to each other. Okay, and do you guys remember what I would do next? Very good. Subtract 3 to both sides. We have 2 cosine x equals negative 2, and then what would I do? Good. Divide by 2. And we get cosine x equals negative 1. So now we need to go to our unit circle. And whenever you get like 1 or 0, oftentimes it's going to be a quadrantal number, basically. So when is our x value negative 1? At pi. And we already had an idea of where it was going to be, right? And so, again, this here tells us that our answer is pi. Okay, questions before I move on to the next one? Okay, number 2. So this one, notice it has a sine function. And so let's go ahead and make some notes on sine functions. So our sine zeros, and actually I should probably put sine with that. Our sine zeros are where?
0 pi 2 pi.
Very good. 0, pi, and 2 pi. And now remember that we have 5 key points. Well, with the sine, our ups and downs are in the middle between these. So same as with cosine, how it starts up, sine also here starts up and then goes down. So when we have 3 zeros, we have the 2 points in the middle of those zeros. And then when we only had 2 zeros, we had them on the outsides in the middle. Make sense? So if you guys can remember these, it will help you a lot. Okay. So now that we have that, let's go and look at our graphs here. So this right here, the negative means what?
It's going to start going down.
Good. So if you want to write start down, that's fine. Whatever makes sense. If you want to put reflect, whatever will help you know what to do. Okay. And then the 3 means that we are going to what? Good. Amplitude of 3. And then the plus 1 means? Very good. Shift up 1. Okay. So we're going to go to our first 0, which is supposed to be at 0. And I just need to do what? Up 1. Make our point. Okay. My second 0 is at pi. And also I'm just going to go up 1. And then 2 pi up 1. Okay, then going in the middle, so this is where my next point would be between 0 and pi, so at pi over 2. This one would normally go up, but because of the negative, we're going to go down. And how many am I going to go down? 3. Remember that you're always starting at that equilibrium line. You're not starting at 0. So starting here, I count 3. 1, 2, 3, and I end up at negative 2. Okay, and then at 3 pi over 2, we're going to go up 1, 2, 3. Are we good? Okay, and then we want to draw our curve. Okay, the next one we have is y equals 2.5. And so if we go up to 2.5, and it's going to be kind of in the middle there, right? And again, a ruler would probably be helpful to make it a little straighter, more accurate. So we have our line. And I'm going to label these. This is g of x. My other equation was f of x. And do we see... How many points does this one intersect? 2. Okay, and so I'm going to kind of mark it here and mark it here. Okay, So looking at your unit circle, okay, what is in between pi and pi over 2? So here is pi and here is pi over 2.
There's 3 pi over 4 and 5 pi over 6.
Yeah, so is this, it's right in the middle, right? So what do you think would be a good guess? 3 pi over 4. I think that's a great guess. And we'll find out algebraically if it's true. I'm not sure. So we're going to write 3 pi over 4. And then same thing here. This one's between pi over 2 and, oh, sorry. I lied. This is between 3 pi over 2 and 2 pi. Do you guys agree? This is pi over 2 right here. So let's go back and adjust. Okay, pi over 2 and 3 pi over 2. What do we want to change that to? What would be right in the middle of these two? Yeah, 7 pi over 4 and also 5 pi over 4, okay? So I'm going to change this one to a 5 pi over 4 and a 7 pi over 4. Does that make sense? My choices? No? Okay, so this point right here, do you see how it's in between pi and 3 pi over 4? Okay, so if you go here on your unit circle to see what fractions, what radians are in between, here's pi, and here is 3 pi over 2. And so it looks like the point is right in the middle, so my guess is 5 pi over 4 for the point that's between those two. Then the next point that it's hitting is in between 3 pi over 2 and 2 pi. And so that one would be, I'm thinking 7 pi over 4. And again, these don't have to be exact. These are just guesses. Okay? Make sense? All right. So now we're going to actually find out the correct answer by setting these equal to each other. So we have negative 3 sine plus 1 equals 2.5. So now we're going to do it algebraically to find the exact answer. Do we have questions right now? Okay, so what am I going to do first? Good. Subtract 1 to both sides. So we get negative 3 sine equals what?
1.5.
Good. And then what will I do? Divide by, good, negative 3. And I forgot my x here, sorry. Divide by negative 3, and I get sine of x equals, and 1.5 divided by negative 3 makes what? Good. Negative 1/2. So what two quadrants are we going to be looking in for a negative sign value? Where is, remember now, sine is dealing with y, correct? So where is y negative?
3 and 4.
Good, 3 and 4. So where is the y value negative 1/2? 7 pi over 6. Good, and 11 pi over 6. Bless you. Okay, so were we exactly correct? No. But does that matter? No, we're just guessing. Okay, so, and also when you're writing these answers, you should be writing them from least to greatest, if possible. If you don't, it's okay. But normally you would see them in order from least to greatest. And then they also put the brackets around both of them, and they're basically telling you that x equals these values. So the sine of 7 pi over 6 is approximately equal to negative 1/2. Okay? Questions? All right. So number 3, we have two different functions. Okay? Sine of x, we're going to graph that first. The only change on that one is what? There's a 2, so that means we're going to have an amplitude of 2. Yes? Did you have a question? Oh, okay. So, sine, where are my zeros for sine? And are those going to be shifting at all? No. Okay, so we make our points at 0 pi, 2 pi. For sine, the next point is in between those two and it always goes up. And that one, it doesn't have a negative in front, so it's going to go up, and I'm going to go up how many?
2.
2, very good. And then in between the other 2 points, I'm going to go down 2, very good. And then we're going to graph. And we'll label that one as our f of x. Okay, now for g of x, we have cosine of x, and the only change on that one is also it has what?
Amplified 2.
Good. So my cosine, where are my zeros at?
Pi over 2 and 3 pi over 2.
Good, pi over 2 and 3 pi over 2. And are those zeros going to be moving at all? No. Okay, so I'm going to go ahead and plot those zeros there. Okay, and then before pi over 2, that one always starts up, correct? And I'm going to go up how many?
2.
2. Okay, here in the middle of my 2 zeros, that one always goes down, and it's going to go down how many? 2. And then after this 0, it's going to go up 2. Okay, and then we're going to draw this curve. And I feel like it's kind of important to do multiple colors because sometimes how the points are, it can be confusing if you're using the same color. Okay. All right, so we can see they kind of connect there at a couple points. Do we want to take a guess again? Okay. And so this one's in between 0 and pi over 2. So between 0 and pi over 2, okay, let's try pi over 4. And on this one, again, it's between pi and 3 pi over 2. And so where do we think that one is?
Pi over 4.
Sure. Okay, so now we are going to solve this one algebraically. And algebraically, this one is just a little bit different. Because we have 2 functions in there. Okay, the first thing that I notice is that they both have 2's in front. Okay, and so I would start by dividing by 2 and eliminating those. Okay, so when I do that and I divide both sides by 2, these cancel, and I get sine of x equals cosine of x. What does sine of x actually represent? What does sine represent?
Y.
Okay, so this is basically saying, when does the y coordinate equal the x coordinate? So if you go and look at your graphs, where is there a value where the x and the y are the same? So we're going to go to our unit circle. And we have an idea that, because you guys realize like this right here is quadrant 1, right? Between pi 0 and pi over 2. And this right here is which quadrant? It goes, like each of these are like markings kind of. This would be quadrant 1.
Yep.
Okay, this would be quadrant 2. This is quadrant 3. And this is quadrant 4. So based on that, what 2 quadrants would we probably find these points in? 1 and 3,
Yeah.
right? Do you see that? So this is 1, 2, 3, 4. Okay, so we're thinking 1 and 3. So, but if you don't know, you can still just look at all your points. In quadrant 1, do you see anything where the x and y coordinates are exactly the same? Where? Pi over 4. Okay, I'm going to put x equals pi over 4. Okay, and then do we see anything in quadrant 2 where they're exactly the same?
Okay, we're moving for quadrant 3.
I know, but I'm just showing you. Do you see anywhere in here that they're exactly the same? No, and it's not possible because one is going to be negative and one's going to be positive anyways. And so this is where they're going to be the same. And which other one? Very good. And we actually guessed correctly this time. Nicely done. Okay, any questions here? Okay, we're gonna turn over to the back and we're actually probably gonna do 4 examples on the back. We're gonna start with one different than what was stated on the front. And that first example I want you to write down is 2 sine theta plus root 2 equals 0. And so for these, we're only gonna be solving them algebraically. And so I want you to go ahead and solve for sine. And remember, we want to get our answers, though, in radians instead of degrees. All right, what did you guys end up getting? Did you guys get answers? Okay, 5 pi over 4 and 7 pi over 4 would be correct. How many of you got it? Just 1? Oh, you haven't finished yet? 2? Okay. While you guys are finishing, I'm going to start it. So the first thing you should have done is subtracted by root 2. Good. So then I have 2 sine theta equals negative root 2. Next, I would divide by 2 to both sides. Okay, so we are solving for theta. Okay, where is sine negative? Where, and remember, sine is dealing with our y coordinate. Okay, so where is y negative?
Quadrants 3 and 4.
Good, quadrants 3 and 4 is correct. So we're going to our unit circle. We're trying to find where is y negative root 2 over 2.
5 pi over 4.
Very good. 5 pi over 4, and then y is negative root 2 over 2 at 7 pi over 4. And so those are answers. Now this time, instead of saying x, we have theta. So I'm going to say theta equals, and again, we want to go in order from least to greatest, and so that's going around on the unit circle. So we have 5 pi over 4, and then we had 7 pi over 4. Questions? Okay, number 5. This time I have 4 cosine squared of theta minus 3 equals 0. What will I do first on this one? Good. Add 3 to both sides. So I have 4 cosine squared of theta equals 3. Next, what will I do? Good. Divide by 4 to both sides. So these cancel. So I have cosine squared of theta equals 3/4. How do I get rid of the cosine squared? Good. Square it both sides. So remember, you're taking the square root of everything. Okay, and what happens when you make a square root? Good. It becomes plus or minus. So I have cosine of theta equals plus or minus root 3 over 2. Very good. So what does that tell you? When it's plus or minus, that means
All 4 quadrants.
very good. All 4 quadrants. So that means I'm going to have how many answers? 4. And I am specifically looking for the x or the y. Very good, the x. Okay, so I'm going to put theta equals, and we're going to go through our unit circle one at a time. So starting in our first quadrant, where do we get the answer for x as root 3 over 2? Pi over 6 is correct. Okay? So make sure you're looking at the correct coordinate, because see how there's a y coordinate that's root 3 over 2? So make sure you remember that cosine is dealing with the x coordinate. Okay? And so pi over 6. Okay, going to quadrant 2. Where is my x, that value? Good, 5 pi over 6. Because it can be positive or negative, correct? Okay, and then quadrant 3, what will it be?
7 pi over 6.
Okay? 7 pi over 6. And then the last one is what? Good. 11 pi over 6. Yes. Yes. Okay, any other questions on this one? No? All right, this next one is where it looks a little different, but I wouldn't say it's more complicated. We have 3 sine theta, and then tangent of theta, plus 3 sine of theta equals 0. Okay, does anybody have any idea of what we may do?
Subtract 3.
If we were to do that, like subtract the 3 sine of theta, you would end up dividing by 3 sine of theta, and when you divide out like sines and stuff, it loses its whatever. I can't think of the word I'm trying to think of, but it's not as accurate, okay? So we don't really want to divide out a sine, but what you're thinking is kind of correct. So we are actually just going to factor out a 3 sine of theta. Do you see how they each have 3 sine of theta? Remember, like if I were to have something like x, or let's say I had 3xy plus just 3x, we could take out the GCF of 3x. Does that make sense?
Yeah.
And so here our GCF is 3 sine theta. Okay,
And all these tangents.
so good. So when we factor out 3 sine theta, okay, we make a parenthesis, okay, which means that we are reducing each of these, right? We're dividing each of them by 3 sine of theta because we are taking out that GCF. And so what are you left with here in the parenthesis? Tangent of theta plus what? Plus 1. Because 3 sine of theta divided by 3 sine of theta would reduce to 1, okay, equals 0. And this should look kind of familiar because we did other problems like this, but this is now that you have your 2 factors, we would set each of our factors equal to 0 and solve, okay? So that means we have 3 sine of theta equals 0 and tangent of theta plus 1 equals 0. On the 3 sine of theta equals 0, we would divide by 3 to both sides, and we get sine of theta equals 0. So sine is dealing with which coordinate? The y. And so where is y 0? Where is it?
Pi 2 pi.
Okay, and we are only going to do it, it's going to be less than 2 pi. And so it's actually going to be 0 and what? So instead of 2 pi, we're going to write 0.
Oh, it's 0 and pi. Oh yeah.
Sorry. Okay. So for sine of theta, it's at 0 and pi. Okay? So it's just going to be all values less than 2 pi. Okay? Now for tangent of theta, we're going to subtract 1 to both sides. We get tangent of theta equals -1. Now tangent is a different story. We know that tangent doesn't represent y or x, it represents what?
Y over x.
Good, y over x. So we need to look at each of our coordinates and decide where would it reduce and make a -1. Okay, and we specifically know that tangent is negative in which 2 quadrants?
1 and 3. Or, no, 1 and 3.
No, 2 and 4.
Oh, 2 and 4.
There we go, 2 and 4. Okay, because remember this is positive and this is negative, which would make a positive. Okay, so we are looking in 2 and 4. So if we go back to our unit circle, remember we're just looking at the numerators. Which ones would reduce? What would make it reduce to -1? 3 pi over 4. Do you see how both of these are root 2's on top? And so if you put them on top of each other and reduce, that would reduce to be -1. Yes, we're good? Okay, see here, that would not reduce. You have root 3 and 1. This is root 3 and 1, so those would not work. So the only one that works is 3 pi over 4. Okay, so here we have 3 pi over 4. And then the other one is going to be what?
7 pi over 4.
Good, 7 pi over 4. Okay, so writing these smallest to greatest, we would go theta equals, and what would I start with? What would be the smallest? 0. Okay, what would come next if we're going smallest to greatest?
3 pi.
Good, 3 pi over 4, because that one's less than 1. And then next would be pi, and then we would have,
7 pi.
good, 7 pi over 4. All right, any questions? Okay, we're going to do one last one. And we're going to label this number 7. Okay, 2 cosine squared theta plus cosine theta minus 1 equals 0. Okay. Thanks. How do you think we'd end up solving this one?
Factor out a cosine theta.
So I can't factor out a cosine theta because do you see how this number 1 doesn't have a cosine theta?
That's how you add it.
No, that's not going to help us either. Okay, so this is what I want you to do. We're going to go let x equal cosine theta. So if I rewrite this and I let x equal cosine theta, I will have 2x squared plus x minus 1 equals 0. Does that look like something you could deal with? I hope you guys remember how to factor.
Yeah.
What do you do when you have a coefficient in front?
Multiply over to the max.
Very good. Multiply over. So my multiplication number is going to be what? Negative 2. And my adding number is what? 1. Okay, so my adding number is 1. Okay, so what numbers will work?
2 negative
2 and negative 1. Okay, because these add to be 1 and they multiply to be negative 2. So then we rewrite this. You guys remember? So we keep the front term the same, 2x squared. And then I'm going to have plus 2x minus 1x minus 1 equals 0. And then what do we do? Very good. We factor by grouping here. And so what is the GCF of my first group?
2x.
Good. And I'm left with
Plus 1.
x plus 1. What's the GCF of my second group?
Negative 1.
And I'm left with?
X plus 1.
Good. And so that ends up factoring to be what?
2x minus 1 times x plus 1.
Very good. 2x minus 1 times x plus 1 equals 0. Do you remember what you do at this point? Good. We're going to equal both of them to 0. So 2x minus 1 equals 0 and x plus 1 equals 0. And so what will this one end up equaling?
Positive 1.
Good. X equals 1/2. And this one will be x equals negative 1. So at the beginning, we said let x equal cosine of theta. So all we're going to do now is substitute back in cosine of theta. So that means cosine of theta equals 1/2 and cosine of theta equals negative 1. Okay, and so we know with cosine, we are dealing with the x. Okay, so that's going to be on both of these, dealing with the x. When is cosine positive? When is x positive? 1 and 4. Good. And so cosine is negative in 2 and 3. Good. So where is, in quadrant 2, where is cosine? Where is the x value 1/2? In 1 and 4, sorry.
Pi over 3 and 5.
Good. Pi over 3 and 5 pi over 3 is correct. So we have pi over 3 and 5 pi over 3. Okay, and then where is cosine negative 1? Well, we said it's somewhere on that left side, but isn't it only really in one spot? Yeah, where is x negative 1? Just at pi. Okay? So we just have pi. And so if we're writing these now in order from least to greatest, theta equals, what would be my smallest? Good, pi over 3. And then next would be,
Pi.
and then,
5.
okay. Any questions?